Sometimes finding an expected count is as simple as performing a generic calculation that you've been calculating probably for years. So in this case, it's said that 10% of the population is left-handed. So if you were to survey 500 people, what would be the expected count of left-handers? I don't need to go to StatCrunch to do this. I would expect 10% of the 500 people that I surveyed to be left-handed. Then that's what I've been told it should be, so that's what I expect. So I can do a simple calculation and say that 50 is my expected value. So sometimes we need StatCrunch to do that for us, or we need to rely on that kind of more complicated formula, but sometimes it's as simple as just reading the question and thinking about it. Okay, a few more things to get us set up this chapter is we have what we call the chi-squared distribution. That's a good approximation for the sampling distribution of the chi-squared statistic if the sample size is large enough. So we do have some conditions we're going to have to check, and large sample size is always one of them. For large sample size in this scenario, we have to make sure each expected count is 5 or higher. So this is a different check. Unlike the normal and t-distributions, the chi-square distribution allows only for positive values. It is usually a right-skewed distribution. If your null hypothesis is true, the chi-squared statistic should be close to 0, and that will give you a large p-value. And if your alternate hypothesis is true, your chi-squared statistic itself should be large, giving you a small p-value. So this one is very similar to the F distribution that we studied in Chapter 11. And just as a reminder, when you're finding that p-value, you always use the area to the right of the observed value. So here would be an image. If this is 0 and my chi-squared statistic falls here, then my p-value has to be in the tail, so it would be to the right